Hi, I'm Steven Martinez, and this is my AP problem number 6. After a 1.0 sample of HI gas is placed into an evacuated 1.0 liter container at 700 Kelvin, the reaction represented above occurs. So, for A, we have to write the expression for the equilibrium constant Kc for the reaction 2HI produces H2 plus I2. So, the concentration, or the K constant, is the concentration of H2 times the concentration of I2 divided by the concentration of HI, and we square the concentration of HI because there's an exponent of 2 on the balanced equation for HI. For B, we have to find the concentration of HI at equilibrium. The concentration of HI at equilibrium is 0.80 molarity. I said the concentration was 0.80 molarity because it starts off at 1 molarity and it decreases down to 0.80 molarity and it stays constant at 0.80 molarity. For C, we have to determine the equilibrium concentrations of H2 gas and I2 gas. So we do an icebox, and we know that the initial of HI is 1, and we subtract it by minus 2x because it has a coefficient of 2, and we know that the equilibrium concentration is 0.8. So we know that the initial for H2 and I2 are 0, and it just gets a plus x because they both have a coefficient of 1. So we just take 1.0 minus 2x is equal to 0.8, and we subtract it by 1.0, so we get negative 2x is equal to negative 0.2, and we divide 0.2 by negative 2, and we get x is equal to 0.1. So the equilibrium concentrations of H2 is equal to 0.1, and the equilibrium concentration of H2 is equal to 0.1. For D, we have to make a sketch that shows how the concentration of H2 gas changes as a function of time. So this is what I sketched for H2, and the graph starts at 0 and hits its equilibrium concentration of 0.1 molarity at the same time HI reaches its equilibrium concentration of 0.8 molarity. And then one line can also be used to represent both H2 and I2 because they have the same concentrations. For E, we have to calculate the value of the following equilibrium constants at 700 Kelvin. For Kc, we use the concentrations we got from problems B and C, and we plug them into the equilibrium expression. So 0.1 squared over 0.8 squared is equal to 0.016. So the K concentration is equal to 0.016. So for Kp, we have to use the equation Kp is equal to Kc times RT to the power of delta N. So delta N is equal to the product coefficients minus the reactant coefficients. So delta N is equal to 2 minus 2, so delta N is equal to 0. So we plug in the K constant and we plug in the Kelvin temperature, and we get Kp is equal to 0.016 times 0.0821 times 700 Kelvin to the 0 power. So the 0 power makes 0.0821 times 700 equal to 1, so Kp is equal to 0.016, so Kp and Kc are equal to each other. F. At 1000 Kelvin, the value of Kc for the reaction is 2.6 times 10 to the negative second power. In an experiment, 0.75 moles of HI gas, 0.10 moles of H2 gas, and 0.5 moles of I2 gas are placed in a 1 liter container and allowed to reach equilibrium at 1000 Kelvin. Determine whether the equilibrium concentration of HI gas will be greater than, equal to, or less than the initial concentration of HI gas. Justify your answer. So we take the given moles and we divide all of them by 1 liter, so we get 0.75 molarity of HI, 0.1 molarity of H2, and 0.5 molarity of I2. So then we plug everything into an icebox, and the equilibrium concentrations are going to be 0.75 minus 2x for 2HI, 0.1 plus x for H2, and 0.5 plus x for I2. Then we get 2.6 times 10 to the negative second power is equal to 0.1 plus x times 0.5 plus x over 0.75 minus 2x squared. Then 2.6 times 10 to the negative second power is equal to 0.05 plus 0.6x plus x squared over 4x squared minus 3.0x plus 0.5625. Then we multiply 4x squared minus 3.x plus 0.5625 over to this side, and then after it's on this side, we subtract everything over from that side to this side, and that's what I did here. So now that everything's equal to 0, we can use the quadratic formula, and we get x equals negative 0.678 plus or minus the square root of 0.678 squared minus 4 times 0.896 times 0.035375 all over 2 times 0.896, and x is equal to negative 0.051. So then we plug the x into the 0.75 minus 2x, so we get 0.75 minus 2 times 0.051 is equal to 0.852. So the concentration of HI increased, and that means the equilibrium concentration is greater than to the initial concentration, because 0.852 molarity is greater than 0.75 molarity.